Hey all, welcome to this mini lesson on algebraic proof. Okay, so many students find this a little bit tricky, and the reason for that is they often don't know how to get started, how to write down the algebra in the first place. So we're going to see how to do that, and then hopefully we'll be able to see how we can get going. So first of all, in this proof here, prove that the sum of any three consecutive even numbers is always a multiple of 6. I want to identify the key words and make sure I'm happy with what they mean. Okay, so three consecutive even numbers. Well, an even number is a multiple of 2, and so I want to think about how to write that algebraically. I'm going to write it as 2n because that's the definition of an even number. That it's 2 times any whole number. That is the 2 times table. So then what do we mean by consecutive? Well, consecutive just means the next one. So if two numbers are consecutive, they're next to each other. And so the next one would just be 2n plus 2. So remember, we don't want the next consecutive number, but we want the next consecutive even number. And so the one after that would be 2n plus 4. And I've added them together because it's the sum that we're looking for. So we've got that. And we just want to prove that it's always a multiple of 6 now. Okay? So how do we prove that it's a multiple of 6? Well, the first thing to look to is, can we simplify? Because that will help us spot anything that we're looking for. So you might see here that we've got 6n plus 6 immediately from just collecting the like terms. And then, well, it helps to think about what it means to be a multiple of 6. And all that it means for it to be a multiple of 6 is that it's some number times by 6. So can we write this in a way where it's obvious that it's some number times by 6? Well, if I factor out a 6, if I take a 6 outside the brackets, oh, I made a little bit of a mess of that, sorry. If I take a 6 out of the brackets, we see here we've got 6 times n plus 1. Well, n plus 1 is just a number. So if it's times by 6, it has to be a multiple of 6. So we've proved it. We've proved it. We've done the proof really nicely. Awesome. Shall we have a look at another example now? A rectangular number is defined as n brackets n plus 1 close brackets. Prove that the sum of any two consecutive rectangular numbers is always double a square number. This one's a bit harder, as you might have seen on the other page. That one was around about a grade 6. This is a grade 8 or 9. Well, again, we do the same thing. We're looking at the sum, and we're looking at consecutive rectangular numbers. Okay. So how do we write out consecutive rectangular numbers? Well, we know what the first one is, because we see that it's n plus 1. But in this case, it's not so obvious, as in the case in the previous question where I just added 2 each time. So actually there's a little trick that always works, and that is to substitute in for n, to write in place of n plus 1, because that will give the next rectangular number. Okay? And this works for any particular kind of number you're talking about. So if we just have a look at even numbers again, remember we said that an even number we could have as 2n. Well, the next even number we wrote as 2n plus 2. But we could have instead substituted in for n n plus 1. And what you'll see is those are actually the same thing. Because if we expand this guy, oh, look, we get the same thing there. We get 2n plus 2. So it's all good. Okay. Ignoring this guy for now. We've written these guys out. So we've got the sum of two consecutive rectangular numbers. And now, so that's step 1. Now we want to see how we can show that it's always double a square number. So we want to simplify. We always want to simplify. So I can do this again by expanding and bringing together the like terms. Now you might notice here that this guy is simply n plus 2 because it's n plus 1 plus 1. So we're going to end up with, looking at the first expression, that will give me n squared plus n. And looking at the second one, well, hopefully you can remember you can do this by a fish method if you like. I always like the fish method. You can do it as a more boring grid method if you like, but you can draw a little fish in here. So it reminds you how to do it. Yeah? So for this guy there, we'll get n squared plus 1n and then plus 2n, so we plus 3n plus 2. Okay, for this guy here, so I'm just going to cross it out, and I've got its expanded version just below. Okay, well that's all rather nice, and I'm just going to finish off over here. So you might now see that if we collect like terms from this guy down here, what we end up with is 2n squared plus 4n plus 2. Okay. Now we want to show it's always double a square number. Now what does it mean for a number to be a square number? Well, we just need to have it times by itself, but we don't know exactly what form it's going to be in. So it could be that you've got n plus 7 squared, or it could be that you've just got n squared, or it could be in any form so long as you've got a whole number squared. So we need a little bit of wiggle room there. Okay. Now for it to be double some number, we want to factor out 2, so that step's a little bit easier. I can see that I can factor out 2 straight away, like so. So I've now got that it's double a number, n squared plus 2n plus 1. But how do I show that's a square number? Now, you might have astutely spotted that this is actually a quadratic. So you can factorize a quadratic. That's often one thing you want to try when you have a quadratic. And you'll see that it factorizes really nicely like that. And look, it's n plus 1 times n plus 1, so it actually turns out to be 2 lots of n plus 1 squared. So this is now a number. N plus 1 is a whole number, isn't it? Because it's just a whole number plus 1. And then squared makes it a square number. And because it's times by 2, it's double a square number. And we've proved it. We've done it. So I can put a QED here because I've finished off the proof. And that's all rather nice. Okay. I might produce a second lesson on algebraic proof just to clear a few things up. You might still have a few questions about it. If you do, feel free to put those in the comment section and don't forget to subscribe down below. Thanks so much for joining us for this lesson, and take care. Cheers.